The hard part, well, there's a couple things. There's two hard things here. There's writing the equation first. That's probably the first stumbling block here. Writing the equation. You need to have a sense of what the graph's going to look like before you try and start. This is a situation where the thing drops. I was thinking that you have this fuel truck and it arrives at the gas station and then the fuel is pumped into the ground, right? Into the fuel tanks underground. That's where the gas is stored for those pumps, right? When you pull up to the pump, there's these enormous fuel tanks underground. So the truck arrives and it has 80,000 liters of fuel. The starting value or initial value is 80,000 liters. That's the y-intercept. Okay? Y-intercept. This value is the y-intercept. The start value or y-intercept. The other number that's here, okay, so you got 80,000, but you also have that number. What does that number represent? 1890 liters per minute. 1890 liters per minute. It's the slope. It's actually negative because it's dropping, right? The fuel in the truck drops, right? Fuel level drops. Now, I didn't make that very clear in the question. Okay, fuel level drops in the truck. Slope is negative, right? Okay, rate of decrease is that. Okay, that's the slope. You have to recognize from a situation those two things, the slope and the y-intercept. The equation then is going to be, here's the basic form, right? mx plus b. And you fill in the two things. Here's the y-intercept. Here's the slope. So what's my equation going to look like? Two ways I could write it. Y equals negative 1890x plus 80,000. Or you could write it with the 80,000 first. Or you could write y equals 80,000 minus 1890x. Either way you could write it. Okay? Those are your two ways of writing the equation. They're the same. If you want to set up the graph, you got to put the equation in first. To put the equation in, go to y equals. If you're putting it in the first way, negative 1890x plus 80,000. Or if you're putting it the other way, it doesn't matter, right? Or if you're putting it the other way, make sure you're doing this right. If you have a minus in between, you got to use that thing. That's the minus, right? The subtraction. Minus 1890x. Those are going to be the same thing. I'm just going to make it so it doesn't graph that one right now. The hard part people have is, let's say they were on a pretty standard window. Let's say they were on Zoom standard, and they say, where's the line? I can't see it. The line's not there. Where is it? Something's wrong with this calculator. You have to have a sense of what the graph's going to look like in your head or on paper here first. What did we say the y-intercept was? What was the y-intercept? 80,000. So it's going to start at 80,000. Let's make a really quick little graph. Let's pretend that this is what's in your head. Here's 80,000. 80,000. And what's going to happen from there? Goes up or down? Up, straight, or down? Fuel level drops, right? So it drops. If you set up Zoom standard, what's the window dimensions here? Zoom standard, the window goes up to 10 on the y-axis. Where's 10 on this graph if that's 80,000? I'm trying to show this much right here. There's my window dimensions, right? You're not going to see the line on there because it doesn't go far enough. What I would suggest is this. I would suggest taking the window and stretching it up this way first so you can see it. Doesn't really look like a rectangle, does it? Stretch the y maximum and y minimum so you can see it. And then try and stretch it out this way. Boy, that I thought was a rectangle. Let's use the actual rectangle tool. So what I would do is start with whatever window you have. Okay, let's pretend your window doesn't show the graph. And then try and stretch it out vertically. Some of you are trying to set all the dimensions first. Stretch it out this way first, and then stretch it out to see the rest of it. So what that means is, don't worry about the x values first. If you know the y-intercept, the only point we know on that graph is this one. The y-intercept. So change the window so you can see that first. don't worry about the X's. Go down and change the min and max. Which one should I change so I can for sure see the y-intercept? What was the y-intercept again? 80,000. So what do I have to go up to at least? 80,000. I would put 90,000 just to make sure it's not right at the top edge of the screen. If you put 80,000 there, it'll be touching the top edge and you might not want that. What should I put as a minimum? 0 would be a good minimum because can you have less than 0 fuel in the truck? You can't have negative fuel in the truck, right? Now, that being said, what I'm going to suggest is that you go negative 10,000 or 20,000. I'll show you why here. If you put 0 and you go graph here, okay, let's ignore the scale here for a second. Actually, let's go back and change the scale. If I'm going 0 to 90,000 by ones, it's putting a mark every one. If I'm going 0 to 90,000, how often is it going to be on the screen, considering there's only 63 pixels from top to bottom? Every pixel is going to have a grid mark, right? The best scale to use is about 1/10 of the distance here. If you're going 90,000, put about 9,000, except for 9,000 is a dumb scale, so put 10,000, right? That would be a good scale. Then it's going to look a little better here. Now, we see the negative part here. Now that you can at least see the line, you can start to work on it. Do we need the negative side of the graph? What quantity is on the horizontal axis? What is x here? What does x represent? For my graph, I have, what's the independent variable here if I had to label this? What is this? What does x represent? Let's move that. Oh, come on. It is minutes, right? It's time in minutes. Time in minutes. What's the vertical? Fuel in liters, right? If you're setting this up, do I want negative amounts of fuel or negative times? Can I have negative x values? No, you don't want negative values here. So then you can start to change the x values. Once you can see the y-intercept and see the line, I'm going to go from 0 here. What should I go up to here? How many minutes do you think? I mean, let's pretend you didn't see it and you said, okay, I'm going to go up to 10 minutes. Look, it's nowhere near being down to the axis here. So then you can just go back and change it. You can just start to experiment and say, okay, I'll go up to 30 minutes. And if I'm going up to 30 minutes, 1 is not a good scale. What might be a nice scale if 30 is your max there, 0 to 30? 2, 5, don't use 3. I mean, you can use 3 or something like that if you want, but 5 is a decent scale. Then it puts a mark every 5. Each one of those represents 5. I didn't quite get it down to 0 here, so maybe I'll go back and what do you think I could go up to? 45 is probably good. If I'm that close to 47 is actually a good scale. Because now, when you trace, you see the numbers on the x values? You see that? Remember, there's a certain number of pixels across here. And it happens to be where the number 47 or twice that much works well. But let's pretend that you didn't care about that and you said 50. Still going to look the same. Okay? It's just that when you trace here, now the numbers are weird. But that's okay. Now you can see the whole thing. That's a decent way to draw the graph. Notice that all of the window dimensions are different. Right? None of them are the same. The only other hint I might give you is you could make the y minimum something negative even though it doesn't make sense, because then when you push trace it doesn't cover up the axis. I'm going to go back and make this a little bit negative here. I'm going to go negative 2,000 or 20,000 because now there's a little space underneath for when I push trace. Okay? If I push trace and do things now, you can do the usual things that I think you know from last time. Second, calculate, right? Value. If you want to know how much fuel there is after 12 minutes, do that. Or 20 minutes, punch it in again. If you want to do the opposite, if you want to put in a y value, you need to. Let's say if you want to know when it's going to be 1/3, it says here, or half full. When is the truck only half full? The only way to do that on the calculator here is to do this. to say half full would be 40,000 liters, and graph a horizontal line there. It graphs a second line there, and then you can find what's called the intersection point. Under this calculate menu, there's this intersect feature. Intersect. It lets you find where those two cross. It's a stupid calculator. It asks you, what two things do you want to find the crossing point? Basically, you can hit enter. That's the first line I want to find. That's the second line. You can go close to where it is and hit enter. It finds that that is the place that it crosses. Okay? After 21.16 minutes. Okay? Okay, for that you need to graph y2 equals 40,000. And find the intersection. Okay, find the intersection. You could answer some of these questions without using the calculator. This is the graphical solution on the calculator. You could do it by just substituting numbers, right? Or sub y equals 40,000 into the equation and solve. Okay, that's if you want to do it algebraically without the graph, right? You should be able to do it both ways, right? Sub that number into the equation and solve it, or use the graph. For any one of these things, you can do it two ways, graphically or algebraically. You can do it two different ways. I was thinking you're going to use the graph most of the time, but you can do it both ways, okay? By subbing in a number and solving something, or by using the calculator. Make sure you're able to do it both ways, okay? That's probably enough said to be able to get you going on this if you're not sure how to do this yet, at least to set up the graph and everything and write the equation.